Hello all, myself Janil. Let us begin understanding Pile Foundation video part 3. In previous two videos, we have learned basic idea and theories of pile foundations like why we need to use pile foundation as my foundation, what are the necessities or what are the types of pile foundation according to different things like method of installation, materials or say etc. Same way, in second video, we have understood theories for using pile foundations like static formula, pile load test, etc. In this lecture, we are going to understand pile and its efficiency as well as grouping action of piles. It is very interesting topic and numericals from this is also asked in GTU. Let us begin understanding this. So, group action of piles. Let us talk about piles now. If there is a column or a single unit or a wall, but below that there cannot be one single pile because driving of one single pile is not very much feasible as well as driving it as vertical as possible, it is also very hard. So what is done in the field is that minimum of 3 piles or group of 3 piles is inserted in a triangular manner when we are only inserting 3 piles, right? But above that there is a reinforced concrete slab or we can say beam and which is acting as a pile cap. Here in 3 single piles you can see a grey colored beam kind of thing or we can say in 3D it is a slab. So this will act as pile cap and total structural load will be on this pile cap and this pile cap will distribute total load in different piles. It is not necessary that pile cap is above the ground line only. It may be buried in the soil or it may be below the ground line. But pile cap will act as a reinforced concrete slab or beam and it will distribute the load to the piles. Now, coming on to the group action or load carrying capacity of pile group. Now here this diagram is showing two images. In this first image we can see Q load is coming on a single pile and single pile have a stress zone or its bearing capacity, load carrying capacity zone is like this in a bulb shape as we have studied in stress distribution. Same way, if the 3 piles are there, all 3 individual zones will be like this. But when we group the piles and it will act as a group of piles, it will have a larger zone. Here you can see a larger zone and it will act as a single pile, but there are more piles, so it will have a larger capacity than some of individual piles. Where reason behind this is the soil in between these piles, this group of piles is compacted or it is fitted in, and due to this interlocking it is having more stress area or it is having more load carrying capacity. So this is a group action of piles. Let us move further how to evaluate that. Pile capacity. First let us understand individual pile capacity. So QU, load carrying capacity ultimate, can be given as small qp into AP plus alpha into C into P into D. Here, small qp can be written as C into NC. We have also discussed these things in bearing capacity chapter, previous chapter. Moving forward to block capacity now. Now we are talking about a group of the pile. So Qg into bracket U, that is ultimate capacity of pile group, can be given as Qp into Ag plus C into Pg into D, where something new things are like this. Ag, that is bearing area of the group of pile. Pg, that is perimeter of the group. C. Cohesion. D. Depth or we can say length of the pile, and alpha, that is adhesion factor. So these are formulas for individual as well as pile block. Moving forward to efficiency of pile group. Now, how to measure efficiency? So, there is a very simple calculation. We can write this: efficiency of pile group is equal to load carrying capacities of pile group upon sum of load carrying capacities of individual piles. So, basically efficiency can be derived from capacity of group by capacity of single one. Moving forward to formula, that is Ng can be written as Qg upon sigma Qu. Moving forward to spacing of piles in a group. So this is general data for spacing. Here 3 times diameter of pile for friction pile. When we are talking about friction pile in the soil, generally it is taken as the space between two piles is taken as 3 times the diameter of the pile. So we can say roughly one pile is there, then 3 pile gap should be kept, and then you should lay your pile. So that is how spacing is kept. And for end bearing piles, 2.5 times diameter of pile is the distance kept for end bearing pile. Moving forward to efficiency of pile group dependencies. So we can say these are the factors affecting efficiency of pile group. First factor is type of soil. So according to which type of soil is there, the pile group is laid, and pile group efficiency will be dependent on, because in loose type of soil there will be lesser efficiency, in hard kind of soil there will be more efficiency. There are chances of efficiency getting lesser also is there. Method of installation. So how do you install your piles, or what is the method feasible at your place is also a factor affecting efficiency of pile group. Spacing of piles. If you are keeping spacing more, then efficiency will be less. But if you are keeping your spacing minimal, there will be more efficiency. Length of piles. If you are keeping the length of pile more, there are chances of load transfer mechanism getting stronger there. Diameter of pile. If you are keeping your diameter of the pile greater there and spacing lesser, there will be more efficiency. But if you are keeping your diameter more and spacing also more, there will be a lesser capacity. Material of pile. Now which material you are using of what strength will depend on efficiency of pile group. Number of piles in a row. So sometimes there are lesser piles in a row, sometimes there are more piles in a row. According to requirement of the situation it is kept. But if there are number of piles more, there will be more efficiency, it is but obvious. And number of rows in a pile. Sometimes if you are keeping 16 piles only, but you are keeping 4 rows. But if you want to keep 16 piles only and keep 2 rows, it is possible. So the strength or efficiency is also dependent on how many rows of piles you are keeping there. So these are the factors. Moving forward to problem number 1. So problem 1 is a efficiency of group or grouping of piles is there. A square pile 3 cross 3 9 piles as shown in the figure are embedded in clayey bed. Now Cu is 100 kPa. Kilopascal can be written as Newton per mm square. The CC spacing, that is the center to center spacing, is kept as 3 into diameter 3d, or we can say 3 times the diameter. The length and the diameter of the piles are 10 meter and 0.3 meter respectively. So diameter and length is given. If alpha adhesion factor is 0.6, calculate pile group capacity. Now it is a friction pile group. Let us write given data first and use the formulas which we have understood previously. Very simple. Given data, C is given as 100 kN per meter square, alpha is 0.6, D given as 0.3 meter as provided in the problem. CC spacing, that is 3 times diameter, so we can write 3 into diameter. Diameter is given as 0.3. So it will be 0.9 meter total spacing. And depth, or we can say length of the pile, is given as 10 meter. So let us consider block failure first. For block failure, QG, group load carrying capacity ultimate of pile group, can be written as C into PG into D. Here the second term is not written because it is a friction pile and it is a clayey bed, right, cohesive soil. Moving forward to putting the values of C, PG and D. Now C and D both are given, very simple. C is given as 100, D is given as 10. There is no issue, but PG is very sensitive here. You can make mistakes. Now PG is what? Perimeter of the group. So we have four sides, right? It is making like a square. So I have to multiply 4 into one side perimeter length of this square. So calculating one side, now center to center spacing is given as 0.9 meter. So this distance is 0.9. Same way this is also 0.9. So 0.9 plus 0.9 will be 1.8 meter, and the remaining length is 2 times the half diameter. So 1 diameter. So 1.8 plus 1 diameter, that will be 2.1. So this total length of one side, that is 2.1, and four sides are there, so I have to multiply 4 into 2.1. That is how QG will come out as 8400 kilonewton. Now calculating individual pile failure or individual pile capacity. So QU is equal to alpha into C into P into D. Now we have to consider everything for individual pile. Alpha is given as 0.6, C 100, D 10. Now for P, perimeter, here we will put 0.3, which is diameter into pi. So we are taking pi into D. Here I am getting individual capacity as 565.48 kilonewton for single pile. Now if you compare 9 piles into 565.48 kilonewton, total capacity will come out as 5089.32 kilonewton. Now if you are calculating 9 individual piles, there is capacity 5089, and if you are calculating it as a block or pile group, it is 8400 kilonewton, having more capacity. But when you are going to design in the field, you should take a lesser value of both of them to be on a safe side. So I will take total capacity of these 9 piles as smaller of these two values, and it is 5089.32 kilonewtons. So that's it for this problem. Problem 2. In a 16 pile group, so there are 16 piles in a group. The pile diameter is given as 0.4 meter and center to center spacing of piles in the square shape. So piles are in the square shape, so 4 cross 4 must be there, and spacing is given as 1.5 meter. C, cohesion is given as 50 kN per meter square. Determine whether failure would occur as a block or when the pile will act individually. So when the failure will occur or when the load is lesser, if it is individual pile or it is a pile group. Moving forward, neglect bearing at the tip of the pile. So end bearing should be neglected, or we are given hint that it is a friction pile, and they are long of 12 meters. So depth of the pile, length of the pile is 12 meter. Take M is equal to 0.7 for shear mobilization around each pile. So it is nothing but our adhesion factor. Sometimes it is termed as M. Also determine the safe load on this group. So we are told to find out safe load on the group. Here there is a square, 4 cross 4 piles. Now let us write down given data. In given data, number of piles are 16, right? Diameter is given as 0.4 per pile. S, spacing is given as 1.5 meter center to center. C, cohesion 50 kN per meter square. D, that is depth of the pile, that is given as 12 meter, and alpha is given as 0.7. Now we have to calculate both the cases as well as safe load. So first case taken as block failure. Now we are calculating the perimeter first. For perimeter we need one side, right? For one side length we have to calculate like this. Center to center distance between two piles is given as 1.5. So 1.5 times 1.5 three times, 1, 2 and 3 times, plus 2 times half diameter, that will be 3 times spacing plus full diameter. So we can write out 3 into 1.5 plus full diameter of one pile, that is 0.4. So total width of one side can be written as 4.9 meter. Now for perimeter we can multiply it with 4 as there are 4 sides, and also neglecting the end bearing. We have to write Qg, or group load carrying capacity, is C into Pg into D. Now Pg can be found out easily, 4 into 4.9, or we can say 4 into B. C is given as 50 and D is given as 12. So putting all the values, I am getting pile group capacity as 11,760 kilonewton. So let us calculate individual pile failure. For this case, we also have to neglect end bearing, or at the tip of the pile there is no resistance. Let us move to QU. For individual pile, we have to take all individual properties. Do remember that. Alpha into C into P into D. Now alpha is given as 0.7, C is given as 50, P, that is perimeter of one pile only. For one pile we are taking pi into D. So pi into 0.4, and depth, that is given as 12. So individual one pile capacity for single pile, that is 527.78 kilonewton. Now there are 16 piles, so multiplying it with 16 for total 16 pile capacity. 16 pile capacity comes out as 8444.60 kilonewton, which is much lesser than the group capacity. So we have to take smaller value of both of them, as we have just discussed. So smaller value is 8000 something. Let us move to safe load. Now for safe load, we have to divide it with factor of safety. Now in this case, factor of safety is not provided in the problem. If it is provided, we should obtain it from there, but in generalized case we have to take factor of safety as 2.5, as it is very sensitive. So dividing the smaller value of both of them, that is 8000 something, by 2.5, it comes out as 3377.80 kilonewton. So this is the safe load you can apply on these pile group. So that is how you can calculate the capacity or safe load on the pile group. That's it in this chapter. Thank you for learning.